All right, so today we're going to look at how to write a word problem as a table, equation, graph, and interpret it. In this situation, it says that the number of kilograms that an object weighs directly varies with the number of pounds. The object that weighs 45 kilograms weighs about 45 pounds. This situation can be represented by y equals 0.45x. So the way we found that is we took 45 and we divided it by 100 and we got 0.45. So in order to find out how many kilograms something weighs, you have to multiply it by 0.45 to convert pounds to kilograms. So in order to create this table, I need to use the information from the situation. Well, the formula for the situation says y equals 0.45 times x. Well, I have a list of x's here, or a domain, and I'm trying to get a list of y's, or a range. How do I do that? Well, x is my input, and y is my output. So in order to find my y's, I take these x values and I plug them into my equation. So in the very first one, I'm going to take y equals 0.45 and replace x, or substitute x with the value 0. 0.5 times 0 equals 0. So when x equals 0, y equals 0. Now I'm going to do it with 31.5. So I write again on my equation. Y equals 0.45, and I replace my x with 31.5, and I multiply in my calculator 0.45 times 31.5, and I get 14.175. You see how I did that? I plugged the x value into the equation and I get my y. Now I'm going to do it with 45, so y equals 0.45 times 45. So when something weighs 45 pounds, it weighs 20.25 kilograms. Now I do it with 60, so I replace my x with the value 60, so 0.45 times 60. And that equals 27. So when something weighs 60 pounds, it weighs 27 kilograms. Okay, so here's what we do next. This is an input-output table that represents what you plug in pounds, you would get out in kilograms. So we're going to write this as an equation in slope-intercept form. But guess what? They already told us the equation in slope-intercept form. It's y equals 0.45 times x, where y is my output and x is my input. Whatever I plug into this equation for x will give me a specific value for y. Now, here's what it's asking me to do. Figure out if something weighs 105 kilograms, how many pounds does it weigh? Well, I know that x in this equation represents pounds and y represents kilograms. So in this equation, I need to work backwards. I need to take my kilograms and replace them for y. So in this, if I rewrite my equation, it's kilograms equals 0.45 times the number of pounds. X's were pounds and y's were kilograms. So I'm going to fill in the information I know. I know something weighed 105 kilograms, and I'm going to fill in 0.45 times the number of x pounds. In order to solve for what x is, I need to do an inverse operation, and I need to divide by 0.45 on both sides. So when I divide 105 by 0.45, I find out that in order to weigh 105 kilograms, something also weighs approximately 233 pounds. So that was the reverse. So in order to solve for kilograms, I plug in pounds. In order to solve for pounds, I had to divide by kilograms. I had to divide by my slope or my rate of change, because in this equation, my slope is 0.45 and I have a y-intercept of 0. I know I have a y-intercept of 0 because I don't have anything listed, and 0 represents nothing. Now, let's go ahead and look over here. In order to graph this, I need to go over to my y-axis, and it says determine and label the values for each y. Well, let's think. So my starting point in this graph is going to be 0, 0. It's going to be the very starting point. Now my y-axis, if I think about this input-output table, my x input represented pounds. So when I plugged in pounds, what did I get out for kilograms? So my y-axis needs to be represented by kilograms, because what I'm plugging in is my x-axis and what I get out is my y-axis. So what I plug in is x, and what I get out is y. So in this case, in this specific situation, I'm plugging in pounds to get out kilograms. So I'm plugging in pounds as my x to get out kilograms. So let's go ahead and see. So we talked about how when you have a linear function, you can have a list of tables, and those table points represent coordinates, because on a graph you have an x and a y. Now on a table you have an x and a y. So I'm going to use these coordinates from my table and graph them. So when x equals 0, so does y. So that is my origin point, and I'm just going to go ahead and graph my origin point. Now I need to look and see what kind of scale this is moving at. It appears to be moving at about 15, so I'm going to do 5s. So 5, 10, 15, 20. Oops. I want my x to be moving by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And my y appears to be moving at 14, so I'm going to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and I'm actually going to go ahead and go backwards because that didn't work out, so I'm probably going to need to increase it by 3s. So 3, 6, 9, 12, 14, nope, 15, 18, 21, 24, 27, 30. That's better because that fits more to scale. So on my graph, I've now got a y-axis that's being scaled by 3s because I want all my information to fit, and I've got an x-axis being scaled by 5s. So again, my x-axis is in pounds, and that's increasing by 5s, and my y-axis is in kilograms, and that's increasing by 3s. So if you need to pause and fill out your graph, go ahead. In order to fill out the graph, I need to refer back to this table. So like I said, each one of these points on the table is a point that can be plotted or a coordinate on this graph. So here, I find my first point. My first point says 0, 0. So I graph my very first point at 0, 0, where x equals 0, so does y. That's also my y-intercept, or where my line would cross the y-axis. Then I look for my next point, 31.5 on the x, so I need to find about 30. So I graph close to 30, and then I go up to about 14. That would be my next point on this graph. Then I go down to 45. On my x-axis, I find 45, and then on my y-axis, I go up to about 20.25. So 45 up to about 21. Then I'm going to go ahead and go to my next point, which is 60, and it goes up to about 27. I am now going to graph this linear function, and I know it's a linear function because it graphs into a perfectly straight line. Now here's what I need to realize. My rate of change, or my slope in this equation, was 0.45. If I take any of my y's and divide them by my x's, my change in y by my change in x, I will get 0.45. Go ahead and try. Divide, let's do the second one. Or let's do the last one. Let's do 27 divided by 60. What do you get? You get 0.45, and that's your slope. Your change in y divided by your change in x. That's your rate of change, or your slope. So let's go ahead and interpret or write a sentence that directly represents the slope. Well, this sentence of what represents and is happening in this graph and also is happening in this table and in this situation is what it's telling me is if I read this equation that for every pound that I plug in, it will decrease 0.45 every time. So for every pound, 1 pound I plug in, my equation or my situation will decrease, well in this my situation is weight, by 0.45. Does that make sense? Or for every pound that I plug in, I multiply it by 0.45 to find the weight in kilograms. Now this one is a little bit more complicated because it is a decimal, so that's why I chose to do this one as your example. Now, as for that, you are going to go through and you are going to fill in the other 2 pages, and the substitute does have a key, so if you need help, ask him. Now, I want you to go ahead and you are going to read the situation, complete the input-output table, and how you do that is when you plug in X, what do you get out for Y? You're going to rewrite it as an equation, which is listed in every situation, and then you are going to analyze the question that they ask you and solve for that missing variable. Now, once you do that, you will label your X and your Y axis. So in this case, my X axis was pounds and my Y axis was kilograms. Once you label that, you go ahead and label and find the scale for the graph that you would like to use. Find the scale for the graph that you would like to use. Then you are going to interpret what's happening in this situation or the rate of change that you see in this graph. And you will interpret that using sentences in this box. So you're going to do that for 4 situations. And if you finish, you are going to complete page 292 in the textbook.